Okay, so this video is going to show you how to graph equations in either polar or Euler form in your TI-84. So there will be three shapes that we will be graphing today. So we will look at how to graph a straight line, a circle, and a spiral. So a straight line will have a general form in Euler form as z equals t e to the I theta. T is your changing variable and theta is the angle that your straight line makes with the positive x-axis. So if we were to graph y equals x in the normal rectangular coordinate system, you know that that's a 45-degree angle, and we are going to use radians. And to graph this, we will be using the parametric function of your GDC. Okay, so we're going to click mode and then we're going to choose parametric form over there. So we're going down here and choose parametric, and then we're going to write that equation into our function over here. So that's allowing you all the way up to 6 functions to graph. Not functions, 6 graphs. So the first is going to be your parametric equations for x and for y. So this is we're going to use t. So when you're in parametric form, when you click this, the default variable is t. Okay, so in Euler form, e to the I theta converts to cis theta I. For polar, so I'm just going to say this is cosine of the angle that we want the line to make with the positive x-axis. So for simplicity, we can use pi over 4. Okay. And then that is going to be similar for y1 t, but we use sine. Okay, also pi over 4. Okay, so the window, we could set the window to standard so that it's from -10 to +10 for both x and y. Okay, so this is your straight line. That means these are your x and y values, and by default the t is maximum at 6.28 2 pi. Okay, so this is how you graph a straight line in the TI-84. So if you want to increase that or make it bigger or extend all the way here, you have to adjust your t value. So for example, you want negative values, so we will let's just say maybe -20 up to, let's say, 20. Okay, so that gives you a longer line. Okay, so it is the values of t that you can change, so you get a longer line. Okay, the next graph that we will look at is the graph of a circle. So a circle will have a general form of r e to the I t, which means that our changing variable is now in the exponent, and we're going to use parametric equations for that, and our r here is the radius. So I'm going to use the second set so that you can see it graphed simultaneously. So for example, let's just do the radius to be 2, and then we can say cosine of our variable t over here, and then 2 sine of our variable t. Okay, so that should give us a circle whose radius is 2. Okay, so that does not look like a circle. We can probably make that square so that it will look more like a circle. So the next thing that we are going to graph is a spiral. So spirals are of the form z equals t e to the it. So we could actually have a variable, a constant beside t. So let me graph that on the third set. So we can say perhaps t cosine of t and then t sine of t. Okay, so we can graph this. Nope, I don't want that window. I want 0 to 2 pi, so that it's a simple spiral with positive t values. So if you want to extend that spiral further, then you can increase t, but making t negative allows for the opposite turn of your spiral. So this is the one that is turning on a negative on a clockwise direction. Okay, so usually t is a parameter called time, and we usually have that to be positive. So that is the best way of graphing your spiral. So perhaps you could introduce a constant, t cos t and 0.2 t sine t. So you could have a different spiral, or you could also increase that. Okay, so that is your spiral. This allows you to actually look at intersections and understand intersections better, instead of just doing everything manually, algebraically.